It was the very first object that visited our vicinity in the solar system from outside the solar system. It moved too fast to be bound to the sun.
When the James Webb Space Telescope captured and released the first real image of Oumuamua, the astronomical community held its breath. After years of speculation, simulations, artist renditions, and indirect data, humanity finally laid eyes on the mysterious interstellar visitor through one of the most advanced eyes ever placed in space. Launched in December 2021, the James Webb Space Telescope, JWST, was primarily designed to peer deep into the cosmos, unveiling the earliest galaxies and peeking into the atmospheres of exoplanets. But in its journey across the vastness of the universe, it turned its attention inward, toward a relic of another star system that had once swept through our own solar neighborhood, Oumuamua. Before we start, please don't forget to like and subscribe to our channel for more updates. Discovered in 2017 by astronomers using the Pan-STARRS telescope in Hawaii, Oumuamua immediately stood apart from any known asteroid or comet. Its trajectory confirmed it was not bound to the gravity of the Sun, making it the first known object from interstellar space to visit our solar system. As it flew past Earth, moving too fast to be captured by the Sun's gravity, it left behind a trail of questions. Its shape, estimated by its fluctuating brightness, appeared cigar-like or perhaps flat like a pancake, and its acceleration couldn't be entirely explained by gravity alone. Some speculated about icy outgassing, others entertained more exotic possibilities, but there was no image. Until now, the James Webb Space Telescope, with its unparalleled sensitivity to infrared light and its sharp resolution, was finally able to fix its gaze on the enigmatic visitor. Even though Oumuamua had passed out of the inner solar system years ago, the telescope's immense capabilities allowed it to track and image the faint, distant object. The resulting image didn't just offer clarity, it redefined understanding. What had previously been a mystery wrapped in speculative models now had form, texture, and a tangible presence in the scientific record. The image revealed a startlingly unique object, elongated but not uniformly so, appearing more irregular and asymmetrical than prior estimates suggested. Its surface bore markings unlike any previously observed on asteroids or comets within the solar system. There were no clear jets or tails like those seen in comets, nor the smooth, cratered surface of familiar asteroids. Instead, the Webb's image showed what looked like layered strata, almost as if the object had been forged in the depths of some alien planetesimal system, battered by foreign processes not yet understood. Perhaps even more intriguing was the material composition hinted at through the telescope's infrared spectroscopy. There were signs of carbon-based compounds, but not the kind expected from typical comets or asteroids. Instead, the spectral signature bore resemblance to tholins, complex organic molecules formed in the presence of cosmic radiation, often found on distant icy bodies like Pluto or Saturn's moon Titan. This strongly indicated that Oumuamua had spent eons traveling through the interstellar medium, its surface chemistry altered by countless years of exposure to galactic cosmic rays. This first ever real image carried weight far beyond mere scientific satisfaction. It served as a bridge between theory and observation, offering a grounded anchor point for all the models that had tried to predict the nature of this object. For years, astronomers argued whether it was a fragment of a larger body, an exotic hydrogen iceberg, a nitrogen slab shed from a distant exo-Pluto, or even a piece of alien technology. Many hypotheses had leaned heavily on limited data. The Webb image didn't settle all debates, but it carved away vast swaths of uncertainty, painting a more complete picture of the object's physical form and likely origin. Scientists pored over every pixel of the image and accompanying data, finding subtle irregularities in its surface that suggested violent history. The ridges and grooves on Oumuamua's body hinted at collisional processes, perhaps even a catastrophic event in a distant star system's early years that had flung it out into the void. These features provided compelling evidence that the object was not an isolated chunk of rock, but rather a broken piece from a much larger celestial body, possibly a dwarf planet or moon that had been shattered in its home system. This implication alone was profound. If Oumuamua was once part of a differentiated body, a world with layers, perhaps even geological activity, it meant that planet formation was not only active in distant systems, but also violent and chaotic enough to eject fragments across light years of space. The fact that such a shard ended up careening into our solar system provided direct evidence of the turbulent nature of planetary systems beyond our own. Further details emerged from the way the sunlight interacted with its surface in the infrared range. The reflection pattern, observed over a range of time as Oumuamua slowly rotated, showed uneven albedo variations. Some regions reflected more light than others, suggesting a variegated surface, partly dust-coated, partly bare. This could imply surface erosion or layering, or that the object had passed close to other stars or cosmic bodies that may have affected its exterior. The James Webb's precise imaging also helped refine the object's rotational behavior. Earlier estimates had guessed that Oumuamua tumbled chaotically through space, rotating on more than one axis. The new data allowed astronomers to observe the subtle flickers of light and shadow across its uneven surface and confirmed this non-principal axis rotation, akin to a poorly thrown football wobbling as it flies. Such motion further supported the idea of a collision or disruption event long ago, an impact powerful enough to jolt the object into such complex rotation before flinging it out into the void. Seeing Oumuamua in detail changed how scientists would approach future interstellar visitors. It wasn't just about one object, it was a window into the dynamic histories of other solar systems. The insight gained from this single image spurred a rush of recalibrations in planetary formation models. If this was the kind of object floating between stars, there could be trillions more, each bearing unique records of their home system's geological and chemical tales. The universe, in a sense, had just mailed us a message in a bottle, and now we could read it with our most sophisticated eyes. Beyond the scientific implications, there was something deeply human about finally seeing Oumuamua. It symbolized a connection to the cosmos that reached beyond our immediate stellar neighborhood. Here was an object born of an unknown star, forged in alien processes, and after journeying through space for potentially millions or even billions of years, it came close enough for us to see it. Not just detect it, but actually see it. The telescope, a marvel of engineering and international cooperation, turned its golden mirrors toward a fleeting speck and brought it into focus, not just for scientists, but for the collective consciousness of humanity. As astronomers debated the image's subtleties, was that a fracture line, or just an optical shadow? Were those surface hollows impact craters or regions where volatile compounds had sublimated? One thing was certain. Oumuamua was unlike anything else in our solar system. It wasn't merely a curiosity. It was a scientific revolution condensed into a singular frame. The James Webb Telescope had done more than take a photograph. It had captured a moment in the history of the universe, a frozen traveler that had escaped the gravity of its origins and wandered across interstellar emptiness until gravity pulled it into the gaze of Earth's observers. The timing of the image, too, was nearly poetic. At a point when astronomy stood on the cusp of a golden age, where exoplanet discoveries were becoming routine, and the search for extraterrestrial life was becoming more focused and technologically driven, seeing Oumuamua up close was a reminder that the universe still had secrets to share, that beyond every new detection lies a potential surprise, that the cosmos isn't just a background to our solar system's story, but an active stage where alien dramas unfold. The image made the abstract real. Before, Oumuamua existed mostly in numbers and artist interpretations. Now it was tangible. People could see its shape, its shadows, its surface texture. For students, enthusiasts, and researchers alike, it offered something that text and theory never could: an anchor to imagination. The image took interstellar space from the realm of science fiction and placed it firmly in scientific fact. It validated years of astronomical labor, confirmed the efficacy of the Webb telescope, and reminded everyone of the boundless potential that lay in looking up. That potential wasn't just about what could be discovered, but how. The success of imaging, Oumuamua provided a test case for tracking and observing faint, fast-moving interstellar objects. Now that it had been done once, astronomers could refine techniques, adjust observation schedules, and prepare for the next visitor, because Oumuamua was unlikely to be the last. Already, telescopes around the world, as well as space-based platforms, were recalibrating their alert systems. New wide-field survey telescopes like the Vera Rubin Observatory would soon begin scanning the skies with unprecedented frequency and depth, likely identifying many more interstellar travelers. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on Oumuamua's image? Do you think it's alien technology? We want to hear from you. Thank you for watching and see you next time.